Hi, welcome to my video on solve an equation, and this one is marked extra. I'll explain that now in a minute. And we're solving an equation which has different roots. So let's turn it over. And the reason why I say this question is extra because it involves different topics in math. So here we go. Solve for x, and I want the real roots. There also could be imaginary roots. Let's check out. So notice I have the cube root of x plus 1 equals the square root of x minus 3. So I can't, if I cube this side, I'll get an x plus 1. If I want to get rid of this one, I got a square, but I can't do that. So what I'm going to do is change the x plus 1 to 1 over 3. That x plus 1 is understood to be to the 1 power, so it's a 1/3. And this is understood to be, that's a square root, so that's a 2. And again, that's a 1. So that's x to the negative 1 to the 1/2. So cube root is 1/3, square root is a half. And again, I need the same roots. So what I'm going to do to get the same roots, I have to make both of these. And what I'm going to do is make them with the same denominator. So 1/3 is 2 over 6 multiplied by 2 over 2. And 1/2, common denominator is 6. 3 times 3 over 3 gives me 3 over 6. So notice both of them now have the same denominators. That means I can do the 6th power of each side. So I have x plus 1, and the 6's cancel, so I get a square. And the 6's cancel, so I get an x minus 3 cubed. So I want to simplify this equation and have it equal to 0. So there's a couple of ways we can do this. One way is I can take x plus 1 and square it, which is x plus 1 times x plus 1. So that's an x squared plus x plus 1 is x squared plus 2x plus 1. So this becomes x squared plus 2x plus 1. And I didn't need that bracket there. Sorry about that, I'll just take that away so it won't interrupt the question. I didn't need that bracket, so I just wipe that out there. Gone. Okay, whitener helps when you make mistakes. Now I need to cube the x minus 3. So the x minus 3 cubed is x minus 3 3 times. So if we take the x minus 3, now I'm going to multiply these two like I did up here by squaring. So that's an x squared first, outside, inside, last. So that's an x minus 3 times x squared minus 6x plus 9. Now I'm going to multiply this binomial by the trinomial. So I'm going to take the x and multiply by these 3. So it's x cubed minus 6x squared plus 9x. Now I'm going to multiply the negative 3 by trinomial to give me negative 3x squared plus 18x minus 27. So that gives me x cubed. The x squareds are negative 9. The x's are 27 minus 27. So check it out. Everything is, so that goes x cubed minus 9x squared. As you can see, I call this question extra because you're doing all this work. Now there's another way to square this, and I just want to show you that trick before I forget it. If you take x minus 2 and square it, what we have is that we have what we call in the unit on in number 2 when I did polynomials 2, I did the Pastel's triangle, and we have Pastel's triangles of 1, 1, 1, 1, 2, 1, and at 1, add these is a 3, add these is a 3, and a 1, and that's a 1, add, that's a 4, add 6, add is a 4 with a 1. So this is the powers. This is a 0, this is the power of 1. So that's a binomial to the 1 power. This is the binomial square. These are the coefficients. So what we have is, we have an A, that's an A plus B. This is A squared plus 2AB plus B squared. And this is a cube then. So this is A cubed plus, we got a 3A squared B plus 3AB squared plus B cubed. So we practice that. If you look at the Pastel's triangle, so notice the 3 goes 3, and it goes, the degree of this, any one of these terms is always 3, but the A goes down, the B goes up. The A 2, notice the A goes 3, 2, 1, and the B is 0, 1, 2, 3. So because this is a square, we're dealing with this one. So this A, if you want the pattern for squaring this, that's an A squared plus 2AB plus B squared. So I did it by FOIL up here, but if you want to take the A, take this is the A, and that's the B. The A squared is X squared. This is 2 times X times 1. So that's a 2 times X times 1. And this is B. B is 1, so that's a 1 squared. So a fast way to square this is by using this shortcut, or you can use the FOIL. And to do this one, we have, if you look at it, we have an X minus 3 cubed. So if you rearrange that to be X plus negative 3 cubed. So remember, because I put the plus there, and the plus makes it better, because then I always can deal with, I have the pattern is, I just read it, show you, is A cubed plus 3AB A squared B plus 3AB squared plus B cubed. So A is X, so that means A is X. So A is X, B is negative 3, A is X, B is negative 3, and if you work that out, you get X being cubed. This is an X squared, so 3 times negative 3 is negative 9, X squared. And this one is, oh, forgot the square on the B here. So that's 9 times 3 is 27, so it's 27x. Negative 3 squared is negative 27. There's another way to do it according to this pattern. If you look over the polynomial 2 section that I did earlier. Or you can work it out like this. So we have, I just wanted to explain that. Now I have to move, I can move everything to the left equal to 0, or I can move, do it this way, leave the x cubed and negative 9x squared, move the x over is negative, plus 27x minus 2x minus 27 minus 1. So I moved these three, this trinomial over here, but I moved them in the order of, to keep them grouped together. So that gives me negative 10x squared plus 25x minus 28. So I work this down to be a cubic. And since I ran out of space, I have another page here ready to go. So here we go. So I took the equation and put it on this page. So this equation is the same as the one that I just had. Now, how do I solve this cubic equation? Well, if you look over the section on cubic, polynomial functions, there's a way that we practice in those videos how to solve this. So what happens in this one, we have a cubic, and it's an x cubed, so we have 3 roots. And I'm going to look over, as a result of 3 roots, I'm going to look over what I looked at in the videos in that unit on polynomial functions. I'm going to look at the Kurdish Rule. So the Kurdish Rule is done by, we got positives, we got negative, we got imaginaries, and we have a total. So I'm going to look at the positive roots. So when we look at this equation, we see that's a plus and that's a minus. That's one change. Minus to a positive is a second change. Positive to a negative is another change. So that's 3 changes. So that means we have 3 positives. But if we have 3 positive roots, real roots, we also have it, if we go down by 2, we can also have 1. So you have 3 real roots, or you have 1 real root. Now, what we got to do now is look at the negative x. So if I take this equation and put negative x in the place of x, let's see what, and I'll show you this because we practiced it when we did, if you did the section, if you did the unit on polynomial functions. So I put a negative x in, that gives me a negative x cubed. Negative x squared is just x squared, so that's a negative 10x squared. That's a negative 25. Oh, yep, that's a negative x. Now I got to put there, I put a negative 1. So that's a negative 25x minus 28 equals 0. So notice now, sign changes. No, there's no sign changes. So that means there's no negative real roots. So there's no negative real roots. So that means this is negative, so we got no negative real roots. So if we got 3 positives, you got no negatives. You got 1 positive, you got no negatives. But there's 3 roots. There's always 3 roots. So if you got 3 positives, no negatives, you can't have any imaginary roots. If you got 1 positive and no negatives, you must have 2 imaginary roots to make up for the total of 3. So that means we know that I can have 3 or 1. So I have at least 1 real positive real root. So I look at the equation, and what I did, I look for, there's no GCF of x. X is not common here, so 0 is not a root. Also, note, look, add up the coefficients. Sorry, if you add up the coefficients, you get negative 28 and 10 is negative 38, and 26 won't give you 0. So 1 is not a root. Why? Because the sum of the coefficients is not 0. So 1 is not a root. So another possibility we have to look at now, we have to look at this equation, and I'm going to write the equation down here. So you wonder why I said this was extra. This definitely reviews the unit on polynomial functions. So we have this equation, so we have a 1 here. So we look at the possible rationals. So this is the P, and this is the Q. So we're looking at the P over the Q. So that means we're looking at negative 28 divided by 1. But because that's a 1, we're just looking at the negative 28. So the possible roots of P over Q, the possible rational or integral roots or rational roots, is the possible roots are plus minus, and you look at the factors of 28. 28 is 1, and I'm going to go over here to pick up the 28. And I'm going to go 2 and 14. And 4 times 7. So I put them in descending order. So 1 times 28, 2 times 14, 4 times 7. And they're all plus minus. I put the plus minus out here with all the factors in here. These are all the possible rational or integral real roots that we have. So we know, we try 1. 1 is not a root because the coefficients don't add up to 0. So 1 can't do it. So how are we going to try 2? Well, we're going to try 2 with synthetic division. So we got a 1, negative 10, 25, so you have to have done the unit on polynomial. You have to gone over to do this question, polynomial functions. So we bring down to 1, multiply, 2, negative 8, multiply, negative 16, and that gives us a 9. That gives us an 18, so that's negative 10. So this is the remainder. Remainder is not 0, so 2 is not a root. So 2 is done. Now I try 4, so I'm just trying them all. 1, negative 10, 25, negative 28. Draw a line, bring down to 1, multiply, 4, add, negative 6, multiply, negative 24, add 1, multiply, 4, add is negative 24 again. The remainder is not 0, so 4 is not a root. So then I try 7. So I'm doing it by trial and error, and I am using synthetic division, which is the fast way to do it. So bring down to 1, multiply, 7, add, negative 3, multiply, negative 21, add 4. 4 times 7 is 28, and lo and behold, we add, we get a 0. So we have a remainder of 0. That means that 7 is a root. 7 is the root of the equation. 7 is a root. Why? Because the remainder came out to be 0. And as a result, we have a depressed equation now. So this is a constant. So that's a constant. That's an x, and that's an x squared. So we have x squared minus 3x plus 4. So we found one root to be 7. Now we're going to see if there's any more real roots. So the quadratic, the factors of 4 to give me a 3. Because there's a plus here, that means the numbers are adding up. So the factors of 4 are 4 and 1 give me a 5. So can't do it. So we have to say that's A, that's B, and this A is 1, B is negative 3, C is 4. So I have to use the quadratic formula. X equals negative B plus or minus square root of B squared minus 4AC all over 2A. So B is negative 3, so that's the negative of a negative 3 plus or minus. B is negative 3. A is 1. C is 4. All over 2A, which is 2 times 1. So that gives me 3 plus or minus. And that's a 9. So that's a 9 minus 16. So we square and we multiply. That gives us a negative 7 over 2. So that's 3 plus or minus. Square root of a negative number is an I. So that's an I root 7 over 2. So notice these are imaginary roots because that's the square root of a negative number. It's not real, so it's imaginary. So the only root that's real is 7. 7 is the only number that's real that'll fit. So if we go back to the equation, if we go back to the equation and just check it quickly, put a 7 in here. 7 plus 1 is 8. Cube root of 8 is 2. Put a 7 here. 7 minus 3 is 4. Square root of 4 is 2. So 7 is the only real root. But there's 2 imaginary roots also. So there's 3 roots altogether. So I just wanted to show you that excellent question that reviews a lot of math. A lot of math in this question. And if you like my video, click the like button. And if you're not a subscriber, click the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and my content that's on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Hope the video was enlightening or helping you think about all the math you need to know. Bye-bye.